This is a limiting reactant type problem right here. Before we talk about any of the chemistry, I want you to consider the following kitchen example. If you have, please put your hands out in front of you like so. If you have 5 slices of bread and 5 slices of meat, how many sandwiches can you make? You know that answer? You already got it. Not a half sandwich, a whole sandwich, okay? Now, considering both things together, the bread and the meat, you combined them in your mind and got the answer so quickly, I want to point out how quickly and correctly you got it. You picked the lowest answer when you said you can make 2 sandwiches. If you only had 5 slices of bread, you would say, I can make 2 sandwiches, assuming you have an infinite amount of meat. If you have 5 slices of meat and a whole loaf of bread, you can only make 5 sandwiches. Together, when you consider 5 slices of bread and 5 slices of meat, you can only make 2 sandwiches, the lowest answer. When we do this limiting reactant type problem, we're going to have an amount in grams of each of these 2 ionic compounds, and we're going to do 2 calculations to figure out the grams of this solid that can be produced, and we're going to pick the lowest answer. So we're going to do 2 calculations, and then we're going to pick the lowest answer. So that means one of the calculations was just kind of like a throwaway to get out of, just to kind of figure out which is the lowest here. Okay? To kind of put some pictures to what's happening here, these 2 ionic compounds are going to be dissolved in solution like this. This is what these 2 beakers here are trying to represent. And I have the ions separated in solution, not in ratios that are appropriate to the formula. For example, this is a 2:3 ratio. I just have 1 of each drawn. These 2 solutions are going to be poured, well, they're going to be poured into each other. And then what's going to happen is that a solid the solid barium sulfate is going to crash to the bottom. And then aluminum and nitrate are going to remain in solution. So this is meant to be a picture, a cartoon of kind of what reaction is happening right here. An amount of these 2 things are going to be poured into each other, like 5 slices of bread or 5 slices of meat. And we are going to figure out how many grams of barium sulfate could be produced, and we're going to pick the lowest answer. Now, these 2 solutions here, they have to be recognized, or they have to be characterized by the volume, just like how much is there, and also by the concentration or molarity. And for the sake of this problem here, I'm just going to kind of come up with some numbers. Let's say we have 0.2 liters of each solution. And let's just say the molarity of each solution is 0.5 moles per liter. Remember, that's a concentration or an amount. Okay? So we have equal volumes, equal molarities, just to kind of keep the math simple right here. We have to do 2 calculations, one with the bread and one with the meat, to figure out how many grams could be of barium sulfate could precipitate or crash out of solution. So I'm going to start with the meat because I think that's just the best part of the sandwich. The aluminum sulfate here. The plan here is to take these numbers, figure out how many grams of aluminum sulfate are present, and then through a 4-step process, figure out how many grams could be produced. And that's going to be figuring out how much, if we have this much meat, how many sandwiches can we make? From here, we want to try to get to grams. So to get to grams, we can start with our periodic table, because what I want to note here is that we want to start with grams of aluminum sulfate and figure out how many grams of barium sulfate could be produced. So let's start with some of these numbers here. And we're going to start with the molecular weight of aluminum sulfate off the periodic table. So I'm going to add up 2 aluminums, 12 oxygens, and 3 sulfurs. Then you get 342 grams per mole. We are doing this step right now. Okay? Now I started with this step here because I want grams as my final answer of this step. And because I have grams already on the top, already where I want it to be, I have to cancel out stuff here. I need to cancel out moles. I am given something in the problem about moles. So I'm going to use that. The unit cancels, and I cross that off my shopping list. Now I need to cancel out liters. Okay. Now, if I were to pick up my calculator right now, I would calculate the grams of aluminum sulfate that were present in the solution. I got 34.2. Oh, could have done that in my head. 0.5 times 0.2. It's almost, is that right? Yeah. Yep. 34.2 grams of aluminum sulfate are present. So now to do, so that in that solution, there are 34.2 grams of aluminum sulfate. Now I'm going to do this second step, getting grams of aluminum sulfate to grams of sandwiches. I'm going to erase the board here. Now this step, circled in green, I said is going to be done in 4 steps. This is our first step. 2, 3, 4. In every step, we want to cancel out a unit here. I need to cancel out grams using the periodic table, and the only formula that's not crossed out is this aluminum sulfate. That is 342 grams per mole. I place it in here so the unit grams can cancel out. In step 3, I'm going to use the balanced chemical reaction to make a word cancel. In my scaffold here, the only word that is also in the balanced chemical reaction is this right here. So this needs to go on the bottom. That means this is going to go on the top, because that's what we're trying to find. How many grams of sandwiches? A word cancels like in every step. Right now, if we were to pick up our calculator, your answer would be in moles of barium sulfate, because those are the only words that aren't crossed out. We need to get to grams. So in going from grams to moles or moles to grams, we add up the formula from our periodic table: 1 barium, 1 sulfur, 4 oxygens. That number is 233 grams per mole. Again, I place this, I either flip it or don't flip it to make a unit cancel. Okay. Because my scaffold has the units grams barium sulfate, I am confident that I'm going to get the number of sandwiches, the grams of sandwiches that could be produced from the meat. Now I can pick up my calculator. And that is 69.9 grams of sandwiches. Now that is just from the meat. We still need to do the calculation of the bread. But I'm going to tidy this up here and put that down in there. Okay. So from the meat, we can potentially make 70 grams of sandwiches, potentially. Now we're going to do the identical setup and run through, but for the bread, and see how many grams of sandwiches can be made with our bread. So same setup here. I'm going to take this solution, concentration and volume, figure out how many grams of barium nitrate are possible, are present, and then taking these grams, I'm going to calculate how much bread could be made. I'm sorry, how many sandwiches could be made in a 4-step process. To get this question mark in grams, I want to get a grams of barium nitrate, and I have something about moles of barium nitrate. Grams to moles, that connection of grams to moles, or grams per mole, again, occurs when we add up from the periodic table: 1 barium, 2 nitrogens, 6 oxygens. That number is 261 grams per mole. I want to make moles cancel. 0.5 moles per liter. Note how the scaffold is guiding me to what to use. I want my answer in grams, so I'm going to protect this unit, but this unit I want to cancel out. This step in my scaffold, I want to cancel out liters, and I only have this in liters. I'm going to put this up here because the scaffold is guiding me to what needs to be canceled. punch this out right here. 0.5 times 0.2, 0.1. 26.1 grams of barium nitrate are present in that solution. So now I'm going to take that number and do the 4-step process, figure out how many grams of sandwiches could be produced. Step 1 is starting this number and formula in your scaffold. Step 2 is adding this formula up from the periodic table. 1 barium, 2 nitrogens, 3 oxygens, 261 grams per mole. And again, I want these units to cancel out, so I'm going to flip this however it needs to be flipped to make the units cancel. Step 3 is gathering from the balanced chemical reaction. Barium nitrate and barium sulfate, my bread and my sandwiches. To make barium nitrate cancel out, I need to put this whole thing downtown. And that means the only place for this to go is upstairs. That is step 3. Step 4, whoops, let me cancel some things out here. I can cancel these words out. But a little math savvy, these also cancel out, so I'm going to go ahead and cancel, just cross those out as well. Step 4 is back to the periodic table to look at here and see what is not crossed out. What chemical formula is not crossed out? My sandwiches. So I'm going to look that formula off the periodic table, add up the 4 oxygens, 1 sulfur, and 1 barium, and it is 233 grams per mole. I'm going to place this in here to make a unit cancel. Top cancels out bottom from the 3-point line. Now, before I pick up my calculator, I want to make sure the grams of barium sulfate are not crossed out. That means that this, however this punches out of my calculator, is going to give me how many grams of bread, grams of sandwiches could be produced. I am getting 23.3 grams. Okay. Back to the beginning. With 5 slices of bread and 5 slices of meat, the lowest answer, 2 sandwiches, is the correct answer because the bread is limiting you. Two calculations were performed, and the lowest answer tells you 2 things. The bread, the barium nitrate, is your limiting reactant. That was just I called this the bread, and that's kind of a coincidence, but that works out well. This is your limiting reactant, the barium nitrate. So if Friday comes along and you need to order something, so that way on Monday you can get back to work, you should tell your boss to order more of this stuff here. A very important task when it comes to predicting the future. The barium nitrate is our limiting reactant. This is how much sandwiches can be produced by Monday. If you need more than this, you should tell your boss right away. Again, prediction of the future. Thank you.